Hi everyone. Good afternoon, guys. Very good afternoon, everyone. How are you all? Hope you're all doing well. Right, we are meeting after a long time in this revision session of highway. Right, so what is that we are doing? You can say. So we are doing this quick revision session of this highway, and up to which part we have done that rigid payment we are doing, and we'll be continuing that part also, that rigid payment. So once that is over, it will be going with this traffic engineering. So with the traffic engineering, it will be the last, you can say, right? Traffic engineering will be the last one to be discussed, right? With that, the revision of this highway completely gets over, you can say. Here, all of you, welcome to Unacademy. Let's crack it, right? Everyone, get ready to crack, all of you. So what is that referral code you have to use and you have to recommend when you are subscribing to the Plus courses, and when you are recommending somebody to the Plus and Iconic courses? What is that referral code you have to recommend? RP Civil is the referral code you have to recommend to get the maximum benefits available, to avail the maximum benefits from Unacademy. Okay, right. So these are all GATE 2024 rankers, those who got AIR 1 in various branches of engineering, you can say, right? Yeah, you are watching from Pakistan. Okay, very good, right? So Naveen, good afternoon. Right, so this is AIR 1, those who got, and you can say up to which one, this 50% off on your GATE subscription, and this offer is valid up to which one, this is 6 months, right? So you can get which one, 6 months extra subscription months you will be getting, right? So don't miss this opportunity, everyone. So what is that a referral code you have to use? RP Civil is the code you have to use, right? And now, so this 12 months GATE subscription you will be getting for which one, this is 14,999. The original price is 27,998, and for this 2026 aspirant 24 month subscription you can take it which one, this 24,999 instead of 49,000, right? Yeah, assalamu alaikum, right? How are you? So RP Civil is the code you have to use, right? Yeah, Dream Lakshya, good afternoon. Neev batch, right? These are the latest batches that started on 17th May, you can say. New batch for this 2026 it was started, and what is it, you can say, these are all the books, printed books you'll be getting delivered to your home within 15 days of your subscription, right? So this is my profile, you can follow me at which, and this is the referral code you have to use always, right? And which part, up to which part we have discussed, you can say. The last class, if you see now, that rigid pavement parts we were discussing, that 22nd lecture, right? This 22nd lecture, and what is that we have discussed? The wheel load stress values we have discussed. These wheel load stress values we have discussed, and after that the warping stress, nature of this warping stress we have seen, and the amount of this warping stress also we have seen, and what is that nature of this frictional stress we have seen, and the amount of this frictional stress also we have seen, right? As now, so the different types of this stresses, their nature and their values we have seen, right? Equations we have seen, right? How to calculate them, right? As now, is it clear now? So shall we move to the next, all of you, right? Yes, actually they will be starting from which one? Yeah, they will be starting, don't worry, right? They will be starting, right? Mostly from June 7th the new batch will be starting, right? That may be okay. So here 26th lecture, quick revision of this heavy engineering, right? Rigid payment, last part you can see features of the, right? So that is your 263 point now, 264 point if you just consider. So all of you had your lunch, everyone lunch over or not? Now here, if you just observe, right, whenever you are having these warping stresses and these frictional stresses and these which one, warping stresses, frictional stresses, and these wheel load stresses, right? So here it is maximum, right? So this is your wheel load stress, and the second one is what, warping stress, Next, what is another one? You can say frictional stress, right? Those are the three types of this stresses we have discussed now. So frictional stresses, right? Whenever you are going for these combinations, right, first we should understand where these individual stresses are, maximum, minimum, and all these things. Now we load stress maximum at which location, that minimum or this least, right? Least at which location, and this is your lesser at which location, right? So lesser is in between this maximum and this least, na? Yes or no? It is higher than this least. Least means, do you have anything lesser than that? That is the least. That is a lesser most one, you can say. That is a lesser most one, na? If you just observe, that is a lesser most one. If you just observe, right? You have to be careful. Now here, tell me, what is that? Wheel load stress is maximum at which location? That is your corner portion, right? And less at which location, you can say that is at the edge portion, and least at which portion? At that is your interior portion, right? If you just observe, now simply supported and this cantilever, right? They are like that only now. Now tell me, for the same loading, same span, maximum bending moment will occur in the simply supported, or maximum bending moment will occur in the simply supported, or the maximum bending moment will occur in the cantilever, you can say. In which one it will occur? Generally, most of my classes will be in English only. All my classes will be in English only. Java Meher, right? My classes will be in English only. English, Hindi I use rarely. Okay, I'm not that much comfortable with Hindi also, right? Little bit I'll be using. कभी कभी use करते हैं, but उतना continuously नहीं use करते. Little bit, little bit. I'm not that much fluent. आसान से नहीं आते मुझे, right? Okay, little bit just manage करने के लिए आते हैं, right? Okay. Warping stresses, right? What are these warping stresses? Yeah, Pavan, good afternoon. So tell me, what are these warping stresses if you just observe? So where these warping stresses are maximum, minimum, you can say. Yeah, in case of these loads, cantilever one is having which one? 75 languages. Okay, right. Cantilever, what is that you can say? Cantilever with the UDL if you just observe, and simply supported beam with UDL. Which one is having maximum bending moment? Tell me. Cantilever with UDL or cantilever with point load will be having which one? This will be having which one? This maximum bending moment compared to the simply supported. Na? Similarly, that a corner will be, yeah, then corner will be the one which is having this cantilever behavior. So cantilever behavior के वजह से so corner portion में stresses ज़्यादा रहते हैं, right? So the wheel load stresses will be maximum. I'll use in between, okay? Don't worry, right? 22 class not shown. Why? It is there. It is there. It is there. I'll send you the link, okay? You just text me. I'll send you the link. Don't worry. Just search with the same name, right, Naveen? Same name you search and you'll find. Okay. So this is corner, edge, and this interior, right? Now understood? So it is free to bend. More free nature is there means, so इसीलिए so more free nature के वजह से right more bending होता है इसमें corner portion में, more bending बोले तो more bending moment रहता है ना इसमें, right? Like that you can say. So here simply supported जैसा रहता है ना, so edge वाला simply supported जैसा रहे तो right less bending, right? It is less free to bend, right? So less free to bend means so less bending moment develop होता है इसमें, right? So like that. Now warping stresses, tell me where who will be resisting this warping? Tell me, कौन resist करता है warping को, folding or warping को? Self weight of this member resist करता है ना, is no? Resistance जो warping के लिए self weight offer करता है ना, is no? So self weight ज़्यादा कहाँ रहता है, right? Where will be the maximum self weight present? Tell me, at the interior portion. Yeah, only thing is you start, right? Is na, dream laksha, you start speaking to people, right? So you start speaking to people and you listen English classes, and you watch English movies, right? Then you can understand, watch English movies with subtitles, then you can understand easily, right? So you have to do the activities in English, then English you can become perfect, yes, na? That is what. Now warping stresses, warping stresses, right? So warping effect will be resisted by whom? You can say that warping effect will be resisted by this self weight, na? Is that no? Self weight. Yeah, actually Java Meher here some people cannot understand Hindi, so that's why I'm unable to use full Hindi also, right? Okay, that's what the reason actually, right? Some people don't know Hindi also at all, right? Okay. So warping stress, right? Warping stress बोले तो resistance है ना, ऐसा ना? Stress means resistance है ना, ऐसा ना? Stress means resistance. That resistance will be resisted by whom? So resistance will be created by whom? Self weight of this concrete, cement concrete panel resistance develop करता है ना, ऐसा ना? So resistance is developed by this self weight. So more self weight where you can find? In the corner portion or edge portion or interior portion. कहाँ मिलता है more self weight हमको? Corner portion में मिलता है क्या, और edge portion में, और interior portion में मिलता? Which one? They are more self weight is available at the interior portion, right? Interior portion में हमको ज़्यादा self weight रहता है, right? So when more self weight is present at the interior portion, more resistance offer करता है ना वो interior portion. So when more self weight is present at that interior, that will be offering more resistance. More resistance means more stress, right? So that is why warping stress is maximum at which portion? Interior portion, right? All sides material is present ना? ऑफलाइन में नहीं चलता, राइट? ऑफलाइन में नहीं चल रहा है अभी. ओके, ऑफलाइन क्लासेस आर ऑलरेडी ओवर. लास्ट ईयर अक्टूबर या नवंबर उस समय में हो गया क्लासेस ऑफलाइन का, अभी नहीं है, राइट? इंटीरियर. नेक्स्ट, लेसर एट विच वन? एड्ज पोर्शन. ऑफलाइन क्लासेस आर ऑलरेडी एंडेड, ओनली ऑनलाइन क्लासेस नाउ लीस्ट एट विच वन? कॉर्नर पोर्शन. बिकॉज कॉर्नर में लेस सल्फेट रहते हैं कि और ज्यादा सल्फेट रहते हैं कॉर्नर में? लेस सल्फेट विल बी प्रेजेंट एट द कॉर्नर ना, इसलिए लेस रेसिस्टेंस ऑफर करते हैं वो कॉर्नर पोर्शन, राइट? सो लाइक दैट. नाउ फ्रिक्शनल स्ट्रेसेस, इफ यू रिमेंबर फ्रिक्शनल स्ट्रेसेस क्या है? एज और इंटीरियर पोर्शन और एज पोर्शन में सेम फ्रिक्शनल स्ट्रेस रहता है ना. इन द एज पोर्शन और इन द इंटीरियर पोर्शन both maximum and that same frictional stress will be present. At the corner it will be 0, right? Now same here, what is it we can write? Frictional stress is maximum at which one? वो इंटीरियर में ज्यादा रहता है और एज में भी ज्यादा रहता है ना, इंटीरियर और which one? एज पोर्शन में. And there is no in between. Least value available at which one? This is a corner portion, right? Like that. Is that clear? समझ में आया क्या सबके लिए ये वाला? This is clear everyone, this point? Maximum stress, it is continuation of previous discussions only, previous class discussions only, right? So this last class happened, Naveen, you check it on which date? 18th May. 18th May 22nd lecture happened, right? So these are all discussed now, check it, right? Clear? Now coming to this, right? If you consider only one stress will be acting at a time, or all the three stresses will be acting together on the member? Tell me. एक ही stress act करता है क्या, और all the three stresses will be acting? Tell me. Member में all the three stresses act करता है ना, ऐसा ना? All the three stresses will be acting on the member ना. What are the all the three stresses will be acting on the member? Wheel load stress, warping stress, as well as frictional stress, right? Now whenever you are considering the stress for the design, which stress we have to consider? Only wheel load stress, only warping stress, only frictional stress, like that can we consider, or combination of all the three we have to consider? Tell me. Combination of all the three we have to consider now. combination of all the three we have to consider, right? So इसलिए हम resultant stress calculate करना ही पड़ेगा definitely, right? So ये तीनों stresses मिलकर resultant stress को calculate करना है, right? So that resultant stress को हम represent करना है कि ये वाला resultant stress है, ये critical stress है, इस stress को resist करने के लिए हम pavement thickness calculate करना, right? So like that. For this resultant stress only we have to design this. For that resultant stress only we have to calculate the thickness, right? And we have to check everything, right? Now what is that a resultant stress? Resultant stresses at various locations. What are the various locations? You can say first one, interior and this edge, no? Edge or interior portion. Now tell me, for this edge or this interior portion, right, where we have to calculate the stress? Tell me the first number one. Bottom or top? Wheel load stress is a dominating stress and a main stress. Now all of you, wheel load stress is a dominating stress and this is a main stress. Now whenever this is your edge or this interior portion, they will be acting like simply supported. If you observe, edge or this interior portions, they are acting like simply supported. Top compression will be there, bottom tension will be there for interior wheel load. Edge wheel load, same top compression, bottom tension. Now tell me, concrete is critical in the tension or compression? Concrete is critical in the tension or compression, everyone? Concrete is critical in the tension or compression? Tension है ना? So हम tension के लिए डिजाइन करना है क्यों और compression के लिए डिजाइन करना? Concrete को tension के लिए डिजाइन करना है ना, ऐसा नो? So ये tension में resist करे तो बिल्कुल compression में resist करेगा ना, definitely, right? If it is capable of resisting in the tension, it can be resisting in the compression, paka, right? There is no doubt in that. So we'll be checking for this tension only. Where you are getting tension? Interior loading, simply supported slab, bottom compression, top tension, bottom tension, top compression. Edge loading, simply supported beam, top compression, bottom tension, right? For interior and edge, both it will be which one? This bottom is the only tension portion. So now whenever it is mentioned as this interior or this edge portion, you are asked to calculate resultant stress. So where we have to calculate? We have to calculate this resultant stress for interior or edge in the bottom one only, definitely, right? Bottom layer only, definitely, right? Bottom most point only, right? Yes, no? Isn't it? Under which condition? They will mention or not mention, you have to calculate at the bottom only. First one, summer plus midday. What is the summer plus this midday condition? If you just observe, resultant stress at the interior will be equal to, so wheel load stress at the interior, warping stress at the interior, and frictional stress at the interior, right? What are the signs we have to apply? Tell me. Bottom portion. So what is that bottom portion? So that a tension will be taken with which sign? Tension positive, you take it. Compression, which sign we have to take it? Compression negative sign we have to consider, right, by default. Now tell me, interior portion, what is the wheel load stress? Yeah, yes, tell me. What is the dream lecture? What is your doubt? Whenever some interior loading is acting at this place, wheel load acting at interior portion, top compression, bottom tension, bottom tension you can say, right? So wheel load stress at the interior bottom will be which one? Tension, right? So we have to write which one? Plus for this. Yeah, you can feel, no problem. You have to complete which one? This if you are doing the BTech from approved college and approved courses you are doing now, then you can write ESC. There is no doubt in that. If college का permission है तो ऐसा वाला college में BTech complete करे तो, right, अपने ESC अप्लाई कर सकते हैं, right? There is no problem in that. Okay, you can apply for ESC. Just only thing is approved. That college must be approved by this government or whatever it is. It's not whether it is a private college or government college, private university, government university, does not matter. Okay. Now warping stress. Summer midday na daytime. What is that? Tell me. Warping stresses. If you just observe daytime, top compression, bottom tension. Right. So we have to consider which one? Warping stress, daytime, bottom tension only, no? Daytime, bottom tension only, right? Daytime, bottom, which one? This is a tension only, right? Warping stress at the interior will be plus, you can say. Frictional stress now, summer, na? In case of this summer, top and bottom both compression only. Summer, na? Top and bottom both compression only. So what it will come? Minus will come. So edge के लिए सेम साइंस रहता है कि और अलग साइंस रहता? For edge portion also you will be getting the same signs na, plus SA plus SWA minus SFU. Frictional stress. So frictional stress, right? Frictional stress. Warping, no, not warping. See here, warping stress summer. You observe. Sorry, warping stress daytime na. Daytime mein. So here if you just observe this Pavan, I told you na, always we have to consider which one is critical conditions, right? Bottom or top you can calculate separately, but whenever you are considering the bottom na, it will be more critical because more tension will come at that place. Why? Among all these three stresses, wheel load stress is more dominating. Where this wheel load stress is tension, automatically that tensile stresses will be dominating. So that is why where the wheel load stress is tension for this edge or interior or corner, there only you have to calculate. Okay, now we understood. So for interior portion or for edge portion, it will be bending like this. Bottom, which one this tension? Top compression. So wheel load stress will be tension at the bottom and compression at the top. So we are taking based on the wheel load stress nature. Okay, understood? Now warping stress, if you just observe, top temperature during the daytime, sun atmospheric temperature will be higher, this bottom temperature T2 will be lesser. So top expansion, bottom contraction. Top expansion will be resisted by this compressive stresses, bottom contraction will be resisted by this tensile stresses. So warping stress daytime, bottom will be tension or compression, Pavan? Warping stress daytime, bottom will be tensile only. Okay, got it? So it will be plus or minus now? Plus na, warping stress will be positive only during the daytime. Daytime na, midday or this daytime. Now similarly, right, what is it? You can write it if you just consider summer midday. Okay, I'll write the second condition in the next slide. Right, these are noted, everyone. This is noted, all of you. Yeah, this is clear. You attend the 22nd class. I think many of you did not come to the 22nd class. Actually, I did not share that link. Directly I have taken the class. Right. That's why many of you did not come to the class. No? Just complete the 22nd lecture. Then it will be good. Okay. I'll share that link. Don't worry. You just text me. I'll be sharing that link. Because directly I came from outside and I was full busy on the day. Just directly I came home and already I came late 5 minutes and I have started immediately the class. Yeah, here. Naveen, what is that you can say? For concrete, tension is critical. Where you are going to get tension, we have to identify first. Yes, no? How to identify? Based on which criteria? Based on this wheel load stress criteria. So why? Wheel load stress is more dominating compared to all other stresses. Wherever that wheel load stress is tension, there you have to take care first. Okay? And where that wheel load stress is tension, tell me. If it is acting at the interior portion, wheel load is acting at the interior portion. So what is that you can say? It is bending like a simply supported slab. Simply supported slab means bottom tension and this top compression. So the last class I have explained it clearly everything. Bottom tension at what is it you can say? Previous class. Bottom tension, top compression. So we'll consider bottom. Edge also, whenever this edge loading is a simply supported beam behavior, so top compression and this bottom tension, so bottom tension, so bottom only we have to consider for edge also. And whenever it is a corner na, top cantilever behavior, top tension and this bottom compression, for this corner resultant stress now we have to consider top, not bottom. Edge at interior, bottom, because wheel load stresses will be tensile at the bottom. Corner loading, that wheel load stress will be tensile at the top, right? You have to consider corner top, interior and edge bottom, right? Is it clear now? Others also, everyone, right? Now second condition at winter midday. Yes, same behavior unlike corner. Winter midday, summer midday we have seen, and this is your winter midday if you just observe. So that is also at the bottom only now by default if nothing is mentioned, right? What is that? You can say resultant stress at this interior will be equal to, that is wheel load stress plus warping stress plus this corner stress. So wheel load resultant stress at the edge will be equal to wheel load stress at the edge, warping stress at the edge, corner stress at the frictional stress at the corner. Now this is your frictional stress at the, that is your frictional stress at the interior, SFI. One second, not corner, frictional stress at the interior. This is frictional stress at which one? Edge. Now tell me, wheel load stress will be bottom only no for interior and edge, bottom tension only no, so plus we have to take it for these two. Warping stress also daytime, bottom tension only no, yes, plus. And in case of this winter, what is that you can say? In case of this winter, top and bottom tension only, right? Top and bottom tension only, right? So top and bottom tension only means this is also plus we have to consider, right? This is also plus we have to consider, you can say, right? Is na? Is it clear? You may get a doubt, sir. In the previous one minus is there. Here you are getting one plus. Directly we could be taking that plus na. Directly we could be taking this na. Why we are taking the previous one with minus also? Why we are taking this previous one minus also? Because is this a wheel load stress depending upon the temperature, or wheel load stress is independent of the temperature? Tell me. The wheel load stress will be independent of this temperature na? So that value may be which one? This is plus 20. So wheel load stress is independent of this summer, winter, daytime, nighttime, right? That is your plus 20, plus 29, let us say, just for an example. So this is also which one? The same plus 29. Okay. Now frictional stress, if you just observe, frictional stress is also F gamma C Lx by 2. Is there any temperature? Is there any daytime, nighttime? Is there any summer, winter inclusion? No. So that frictional stress is also same for summer, winter. Only the nature is same, but amount is same. So for this, what is there? You can say minus 1. That is very small value. Minus 1. Here it will become this plus 1. But warping stress, tell me. That warping stress is depending upon the temperature, definitely na. Warping stress is depending upon the temperature, definitely. So tell me which temperature will be higher? Summer daytime temperature effect will be higher, or this winter daytime temperature effect will be higher? All of you. Summer daytime temperature will be higher, or winter daytime temperature will be higher? Tell me, all of you. Summer daytime temperature is higher na. So warping stress during the summer midday will be higher, or winter midday will be higher? Tell me. Warping stress during this summer midday may be higher na. So this is 20, let us say 29 plus 20, right? What it comes to be? 20 plus 20, 40, 48, right? That is your 48 kg per this centimeter square, right? Like that you are getting. Now here, so summer daytime warping stress is higher, winter daytime warping stress will be lesser, isn't it? So it will be 18 only. You can it can be which one? This 17 only, you can say, if you just observe, right? It is, let us say, 17 only. How much it will be? Then 20, 30, 47. That is your 47 kg per this centimeter square. Now there is a possibility that this with minus may be having higher stress compared to this with plus na, depending upon the summer daytime temperature and this winter daytime temperature that is varying na, or sometimes this may be higher. So this is 29 plus this 19, even though it is lesser, plus 1, right? How much it comes to be? 49 it comes to be. So that is there 48 only it may be happening, right? But still warping stress in the summer midday is higher than the winter midday. Winter midday 19 and summer midday 20. Yes, now that's condition is satisfied, but if the difference is very much larger na, this will be critical. If the difference is smaller na, this winter midday condition is critical. Correct? Got it now everyone? Understood? When is that condition summer midday is critical and when is that winter midday is critical? All of you? Yes, now this is for edge and this interior loading. Got it now? Now whenever it is a corner conditions, for this corner, top is better to consider for critical or bottom is better to consider for critical? Tell me. Corner top is better to consider na? Top is better to consider, right? And what is that condition? We have to take it only one condition, that is your winter midnight. Because it is acting like a, whenever that corner load is acting, it is acting like a cantilever member. So for this cantilever, top tension, bottom compression will occur. Is not? Winter midnight condition consider kare to kya hoga idhar? What will happen here? That the resultant stress at the corner will be equal to V load stress at the corner, warping stress at the corner, frictional stress at the corner. But we know that, okay, so this is a plus. Why? V load stress at the corner will be plus because it is acting like a cantilever. For cantilever, top tension, bottom compression. Warping stress at the top during night time na? So during this night time, what is that warping stress at the top? Tension. Warping stress at the bottom? Compression. We are interested in top na? Warping stress at the top will be tension only. So tension plus. Winter. Whenever it is a winter, if you just observe, what is it? At this interior edge at this corner, that top and bottom it is tension only. Top and bottom tension means it will become this positive only, no? But what happens here? Tell me here. But what happens? Tell me that frictional stress at corner will be approximately taken equal to 0. Okay? Yeah, we want tension only. We don't want compression. Got it? So this is about your stresses, right? This is about your which one? This is stresses, you can say, right? Yes, na? Clear now? Shall we go on to the next? There are different kinds of these joints we are having. Joints in the rigid pavement. So stresses gets over. Joints if we discuss now, then this rigid pavement mostly gets over, you can say, right? What are these different joints, you can say? One is your longitudinal joints. Longitudinal joints, right? What are these longitudinal joints, you can say? These are mainly for which purpose, you can say? To take care of this warping. Yeah, it can be anything, right? That is what I am saying, right? It can be. So suppose if it is like this na, so this is V load stress and this frictional stress will be same. If warping stress in the summer midday is 20 and winter midday is 17 na, then which one is critical? This summer midday is critical. And warping stress in the summer midday is 20 and winter midday is 19 na, then which one is critical? This winter midday is critical. It can be anything depending upon the difference in summer midday temperature to winter midday temperature. So that's why we have to consider both summer midday as well as this winter midday conditions both. Now coming to this, right, what are these lateral joints? Tell me. Lateral, or you can also call it as which one? This is transverse joints na. What are the two types of this lateral or this transverse joints, you can say? Here in this first one is what? Expansion joint. To take care of which one? Expansion. And what is the next one? Contraction joint, right? What is the purpose of this one? to take care of this contraction. Okay, right. Note this and tell me. Once it is clear, not done, once what tell me, we'll try to go for that. Joints, individual joints will stay. Yeah, the double bar, tie bar, and everything will come into picture here, right? Yes. Suppose whenever you are considering this payment, na, here this is very big panel, you can say. Gap, that gap is there. What is the gap, you can say? That is your joint. This is how the joints will be provided on these, you can say. So now how your vehicle will be running, if you just consider your vehicle will be running in this manner. Now let us say your vehicle is running in this manner, you can say, right? So what is this W? That is your W, or this B is a symbol we are using for this width of this pavement, na? Like that. Now here there are different joints we are having, right? So what is this joint? Tell me. What are these joints? If you just observe, these are present along the length of this road, na? When these are present along the length of this road, right, these are called as your longitudinal joint. That is your longitudinal joints, right? So these are your longitudinal joints, right? So what are the bars present on these longitudinal joints? Tell me. The steel reinforcement bars which are present on the longitudinal joint are called with which name? All of you? The bars present on the longitudinal joint are called as your tie bars. Okay? The bars which are present on the longitudinal joint are tie bars. Okay? Is it clear, everyone? Tie bar. These are your tie bars present on the longitudinal joint, you can say. Is not? No. Next, what is this joint? You can say, right, this joint and this joint and this joint, right? One joint with gap, one joint without gap, right? Both are called with which name? Transverse or this lateral joints, right? Both are in the width direction of this road, na? So they are called with which name? Transverse joints. Okay? But among these transverse joints, the joint with the gap is called as what? Expansion joint. The joint with the gap is called as your expansion joint, and the joint without a gap is called as what? Contraction joint. Is it clear now? Two transverse joints will be there. Joint with expansion is your joint with gap. Transverse joint with gap is your expansion joint. Transverse joint without gap is your contraction joint. Tell me, what are these steel bars present on these transverse joints? Tell me. What are these transverse joints? What are these bars present on these transverse joints? Tell me. What is the name of these bars, if you just observe? Right? What are these bars called as? Those are called as your double bars. Okay? These bars are, whether these bars are present on the expansion joint or these bars are present on the contraction joint. Right? What are these called as? These are called as your double bars if you just observe, right? Yes, na? These are called as your double bars, you can say, yes, na? Now, here, so the spacing between the expansion joints will be given with which symbol? That capital L suffix E. Spacing between the expansion joints. And what is the gap at the expansion joint? We are giving the symbol delta. So delta is the symbol we are giving for gap at the expansion joint. Yeah. Yes, in that transverse joints only, right? Lateral or this transverse joints only. One kind of joint is expansion, one kind of joint is transverse contraction. So this expansion joint as well as this contraction joint, both are transverse joints only. Is not both are transverse joints only. Got it? Under the transverse means what? They are in the width direction. So this expansion joint is in the width direction of rod. This contraction joint is also in the width direction of the rod. This longitudinal joint is in the length direction of the rod. Understood? So both expansion as well as contraction joints will be in the width direction of the rod. With gap is called as your expansion joint, without gap is called as your contraction joint. Clear now? Pavan and Naveen? Right? So like that will be having. Now here, what is that here you are having? If you just observe here, expansion joints, right? What is that spacing between the spacing between the contraction joints, right? That Lx will be the spacing between the contraction joints now. What is that Ly? You can say Ly is the spacing between the longitudinal joints now. So this is your Ly is the spacing between this longitudinal joints, and what is it? You can say this Lx is the spacing between the contraction joints. Is no? Like that. Okay. No. So whenever it is that expansion joint, if you just observe. So what is that expansion joint if you just observe? It is mainly for which purpose? You can say to take care of what? Expansion. To take care of expansion. And why that expansion will occur? Tell me. When there is a rise in temperature or fall in temperature. Since a rise in temperature above construction temperature, na? That is what? With respect to this construction temperature, if the temperature is increased at a particular time, na, then expansion will occur. To take care of this, right, we are using which one? This expansion joint. Okay. To take care of this, right, what is it we are using? We are using this expansion joint. You can say if you just consider. Right. Got it now? Right. Clear? Right. So now, so we have to calculate design of this joints is nothing but you are calculating this LE and this delta values, na? So no. So how can you get that if you just observe? Right. Here you can say this is your panel. If you are just that is your in the plan view, na? If you are considering the side view, what happens? Now like this we are having. So here even though the gap is delta, but we fill this entire gap delta? We do not fill this entire gap delta. Even though delta gap is required, right, we'll be filling only which one? This delta by 2 gap, right? Remaining delta by 2 we'll keep it free, right? Delta by 2 gap we'll fill it. So this side, what is it? You can say this is your delta by 4, and this side if you just observe, what is the delta by 4? Central portion is delta by 2. This is your delta by 4. So total left side and right side, how much it is expanding? That LE is central portion. that LE central portion is expanding left side and right side together. How much? Left side delta by 4 plus this right side delta by 4 free. So total it is delta by 4 plus delta by 4, delta by 2 free now. So it is expanding delta by 4 this side, delta by 4 this side. So total together delta by 2 expansion it is having. Why we are allowing this delta by 2 only, right? Why we are not allowing the full expansion delta? Because during the summer these are expanding and these gaps are filled like this. Okay, that is fine. But during the winter what happens? These are contracting and this gap is increasing further. It is dangerous now. So it is better you allow this full expansion or don't allow. It is better you don't allow this full expansion now. Clear now? Right, note this and tell me. LE is the spacing of expansion joint. Delta is the gap at expansion joint. Right, note this and tell me everyone. Clear now? This one? Once clear, note down. Once want to tell me all of you. Right? Shall I move on to the next? Done? What slide shall I move on to? No. So what is it you can say here if you just observe? As per IRC. What is it as per IRC you can say? So this only you make it as your short notes, right? Yes, no? For all subjects I will be doing like this only, right? So because highway is over, I am doing this for highway na. Now surveying also will be over in the June 1st week. I will be starting for surveying also once highway over. After that June 7th onwards I will be starting the strength of material subject. Once the strength of material is over, I will be doing the revision of the strength of material also and all the questions, right? Like that. For every plus subject I am doing, it will be happening like that, okay? Don't miss. As per this IRC, right? What is it as per this IRC? You can say if you just observe. So that gap at expansion joint. What is it? Gap at expansion joint you can say. And spacing at expansion joint. Spacing of. No, traffic. What about the traffic? We should complete the traffic also, no? Traffic also will be there, no? So we'll do traffic. Already that for traffic also already classes are scheduled, it seems. I have given the list already to them. So that is gap at expansion joint, that delta should not be greater than which one? This is 2.5 centimeter, right? That gap should not be greater than this 2.5 centimeters, right? And that is spacing of this expansion joint, that LE should not be greater than which one? This 140 meters you can say, okay? That is about your expansion joint, right? Clear everyone? 268. Expansion joint is clear everyone? Yeah, the 269th point, right? What is it you can say? Contraction joints. So what are the contraction joints? Expansion joints are for which purpose? Tell me. Expansion joints are to take care of which one? This expansion. Na? Contraction joints are for which purpose? You can say these are to take care of this contraction. Na? These are mainly for which purpose? Right? To take care of contraction, isn't it? To take care of contraction. Right? Why this contraction occurs if you just observe? Why this contraction occurs? Tell me. This contraction occurs due to which one? This since here it is rise in temperature, here it will be fall in temperature. Na? Fall in temperature. Right? What is the reason? Tell me. That is due to this fall in temperature with respect to what? Fall in temperature below construction temperature. Na? Below construction temperature, right? Now tell me, so what is that? You can say if you just observe spacing of contraction joint side, what is the symbol given? LX is the symbol given, na? Length of panel or spacing of contraction joint, both are same. spacing of this contraction joints, right? What is that you can say? That is Lx. No? What is the Lx? Tell me. Spacing of this contraction joint. That Lx will be equal to, right? What is it you can say? Anyone having idea? 2 sigma Ct divided by which one? This gamma C into that small f. This is without double bars. So when double bars are not there, only concrete is resisting that contraction, then this is the value we have to use it, right? And it should not be greater than which one? And this value, this spacing should not be greater than which one? This is 4.5 meters as per IRC. Okay? Now, with the double bar, how much it comes to be? That Lx equal to 2 into that sigma st into that a phi divided by which one? That f into gamma suffix c into h into that s. This one we have to use. This is with double bars. So whenever it is with double bars means it is your PSC or it is RCC. You can say it is RCC type na, like that. And there is no restriction for this spacing. You can say when steel bars are provided. Got it? When steel bars are provided, is na? Right? Note this and tell me what are all these. I'll write in the next slide. Done? Okay. Now what is the sigma Ct? You can say that sigma Ct will be your which one? This it is your permissible tensile stress in concrete, na? Permissible tensile stress in concrete. And what is the sigma St? You can say permissible tensile stress in steel, na? That is your sigma St. Now what is the gamma C? Density of concrete, na? Density of concrete. Okay. And what is the F? You can say it is a coefficient of friction between what? Tell me. Coefficient of friction between this CC panel, cement concrete panel, and its soil and its supporting soil. Like that. And what is the H? You can say H is your what? Thickness of what? Thickness of this CC pavement, if you just observe. SC is what? SC is what? Spacing of this double bars. Is not? Spacing of this double bars, you can say, right? So these are your double bars now. So these are your double bars, right? What is that? You can say that spacing is yes. Here also this is spacing of this double bars is given as yes, you can say. Is not? Like that. That is your 269th point. Now 270th point, this last point we'll see and we'll close. With that, joints gets over. In the next class, we'll be starting which one? This is traffic engineering mostly. Okay. So what is that? If you just observe longitudinal joints now. And what is one more thing left? A phi. What is the A phi? You can say A phi is nothing but your pi by 4 into that phi square, right? So it means area of cross section of one double bar. Now how many double bars? Tell me. That is your one double bar. Okay. Next, longitudinal joints, right? What are these longitudinal joints? If we are just observing, These are for mainly for which purpose, tell me? These are mainly to take care of what? Warping. In which direction? Length. Sorry, warping in the width direction. How can you reduce warping in the width direction? By reducing the width dimension, right? Warping in width direction by reducing it. By reducing which one? By reducing that width value, you can say is now. Now here, so what is that we have to do? Simple folding. Warping means folding. In the last class I explained that, right? Warping means simply folding. Okay, folding like this. Suppose if the width of this pavement, capital D is greater than this 4.5 meters, right? Then what is that we have to provide? We have to provide which one? This long joint can be provided, na? Yeah, you cover the class. Long joints are provided compulsorily. So what is that number of longitudinal joints, tell me? That the number of longitudinal joints will be how much? That number of longitudinal joints will be equal to that number of lanes, right? If 2 lane 1 joint, 3 lane 2 joint, number of lanes of this carriageway -1 we have to select, right? Like that. Okay, note this and tell me. Then we'll go for some points under this. These are the purposes for which longitudinal joints are provided as, na? And how to provide. So that means what is that you can say? It means that 1 joint per lane, na? 1 joint per which one? This every 3.5 meter width. 1 joint per every 3.5 meter width, right? Okay, you add that point also. Done, everyone? No. So that is your 271. What is that? 271th point you can say, right? Minimum length of this tie bar, right? Whenever you are providing this longitudinal joint like this, na? So this you take it as which one? This LX you take it as 1. Then what is this, right? This is your LY. This is your LY, right? That B has become this LY, na? This is your total width of this pavement whenever you are providing this. So this has become this LY, na? So because of this vehicles, right? One vehicle is moving in this direction and some other vehicles are moving in the opposite direction. There is a possibility that these two panels will get separated, na? This panel will be moving like this. This panel will be moving like this. To hold them together, we are providing the tie bars, right? With the proper bonding between them. So for that purpose, right, we have to embed it such that full bonding is ensured, right? For full bonding to be ensured, right, minimum how much length we have to insert? We have to insert for a length of LD inside that side and LD inside this side. So now tell me, what is the minimum length of this tie bar? Minimum length of the tie bars, tell me how much? Small L you can use, right? That LT will be equal to that 2 times that LD, right? What is that 2 times that LD? 5 sigma ST by 4 sigma B, or 5 sigma ST by 4 tau BD, right? Do you remember this in case of this work, right? In your from your RCC development length, right? Is not? So now that a diameter of this tie bar, how much we have to take? It should not be greater than this 20 millimeter. And now, right, what is it you can say? Spacing of this tie bars, no? Spacing of this tie bar, right? What is the spacing of this tie bars? Tell me. Yes, will be equal to A phi into sigma st divided by which one? This F gamma c Ly h. And any spacing is allowed or any spacing is not allowed? This is spacing should not be greater than which one? This spacing of this tie bars is, yes, you can say how much it is. That should not be greater than which one? This is 750 millimeter center to center. Like this is about your which one? This tie bars. Okay. So what is that A phi? Pi by 4 into which one? This is phi square. Yeah, Pavan, tell me. It is the area of this one tie bar, na? Cross section. Is not F we know, gamma c we know, Ly we know, width of this panel, right? What is the H we know, everything we know. That is sigma b will be equal to that tau bd equal to, what is it? Permissible bond stress. I did not get you. Tie bar expression means which expression? Length expression or spacing expression? Tau bd equal to permissible bond stress. Yeah, F gamma c Ly h. F gamma c Ly h. Yes, F gamma c Ly h. Yeah, length 4 tau bd. 5 sigma st by 4 times that sigma b. Instead of this sigma b, we can use it as which one? This tau bd also. So yeah, 2 times. No, sorry, 2 times. Yes, 2 times it will come. Yeah, the 2 is missing. Yes, correct. 2 is missing. Yes. Got it now? Now it is okay? Yes, 2 times. The 2 is missing. Permissible bond stress between which one? This is steel and concrete. Na? Steel and concrete. Clear everyone now? Next we will be entering into the next class, and mostly in the next class that rigid pavement will get over, right? So we can enter into the traffic engineering, right? For working professional, minimum how much time it is available, that much time you have to give it, right? Okay. Minimum means how much free time you are available. Instead of talking to your girlfriend and all these things, na, you focus only on the study, right? 3 hours available, 3 hours, 4 hours available, 4 hours free, 5 hours available, 5 hours free. Utilize for study only. Okay. Because for others, na, those who are completely focusing on preparation, full time is available, 7 hours, 8 hours daily. But for you, less time available because you have to take care of the job. So at least daily 5 to 6 hours we have to go for. So you have to go for which one? This 5 to 6 hours definitely. Okay. Definitely minimum 5 to 6 hours you have to give, right? Otherwise it won't work out. Right? Clear everyone? Any doubts? Anyone? Anywhere? Anyone having any doubts anywhere? Shall I close? If any doubts, I'll just discuss. Otherwise, I'll close the session. Shall I close? Okay. Thank you. Thank you all of you. I'll close the session. Thank you everyone.